Hello, we are discussing about GATE 2003 ECE paper and the topic is related to digital circuits. A 0 to 6 counter consists of 3 flip-flops and a combination circuit of 2 input gates. The combination circuit consists of 1 AND gate, 1 OR gate, 1 AND gate and 1 OR gate, 2 AND gates. What will be the right answer for this one? The counter is counting from 0 to 6 and the counter consisting of 3 flip-flops. Whenever there are 3 flip-flops, assume that one there are 3 flip-flops and the names of that one is nothing but A, B, C are going to be flip-flops. And it is starting from 0, 0, 0 and it is going towards 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0. It is going through all these states from 0 to 6. This is 0th state and it is 6th state. So it is going through 0 to 6 and whenever it tries to go to 1, 1, 1 at that time, this is unused state. From that one it has to go back to initial state. So whenever the counter try to go into 1, 1, 1 state, at that time the counter has to reset itself. That is nothing but whenever this is taking place, by that time resetting of all flip-flops has to take place. Resetting of all flip-flops to 0. Reset implies nothing but you are making the output of flip-flops is 0. Resetting of all flip-flops should be done. So resetting of all flip-flops should be done implies nothing but reset input. Every flip-flop will be consisting of 2 asynchronous inputs. One is preset, the other is reset. So reset input has to be activated whenever the counter try to move towards 1, 1, 1 state, that is unused state. Since this 1, 1, 1 is going to be unused state, whenever that counter is try to enter into unused state, at that time the reset asynchronous input has to be activated. That will make the output of flip-flops to 0 irrespective of clock pulse. That's why only it is called as asynchronous. It is not synchronized with clock pulse. Whenever it is 0 at that time, whenever it is activated, by that time it will make the outputs of all flip-flops to 0. So it is going into the initial state and again it goes to count in up direction towards 6, and whenever again it is going towards 7, and again it will be making the reset. So it will count in between 0 to 6 only. So those are the 3 flip-flops now I am writing. So let us assume these are the 3 flip-flops. Okay, these are the 3 flip-flops and it has some additional circuitry. Okay, this is A and it is B, this is C. Okay, and there will be a clock pulse will be given for the original that is LSB flip-flop. LSB flip-flop only we will give the clock pulse, and the output of LSB is going to be act as clock for the next one, and output of B is going to be acting as clock for the next one, that is MSB. So now you are available with A input and B input, okay, and C input, sorry, A input and B input and C input. So this is what the B input, which is acting as, okay, clock for the next flip-flop as well as the output of B, and this is going to be acting as like this. So here you are going to get the values. This is A, B and it is C, and we have a reset pin, and assume that one reset pin is going to be active high because it is not mentioned anything. So this is going to be treated as reset pin, or it is also called as clear pin, CLR. CLR implies nothing but clear pin, that is used to reset the flip-flops. Okay, this is asynchronous pin, remember that one. Clear, that we are writing it as CLR. It is asynchronous input. It is not synchronized with clock pulse, so it doesn't wait for the clock edge to do its function. Okay, it will perform the reset operation whenever it is activated, and it doesn't wait for the clock edge. That's why it is called as asynchronous. It is not synchronizing with clock. It is not waiting for the clock to appear, whereas the other inputs, that is inputs of flip-flops, are going to be treated as synchronous inputs. Okay, so we have a circuit, we should have a circuit. This is going to be a combinational circuit. So there is a combinational circuit. Okay, for that one the output has to be connected to the reset. That is nothing but clear input, clear of all flip-flops. This output of combinational circuit has to be connected to clear input of all flip-flops, and the inputs readily available for this one is nothing but A, B, C. A, B, C are going to be readily available, that is outputs of flip-flops. Okay, now what is the meaning of this one? Whenever 0 0 0 at that time, let us assume you are going with the 0 0 0 combination. If A, B, C are at 0 0 0, that is A 0, B 0, C 0, by that time you must not get the reset operation. By that time the clear input must be 0. Okay, here you must get 0. Okay, for 0 0 1 also you must get 0. Okay, you must get 0. So the reset pin is going to be, I am writing over here, reset operation, or it is also called as clear pin. Clear pin should be, it is assume that one clear pin is active high. This is active high clear pin, active high clear, active high clear. So it will do the reset operation whenever it is given logic 1. So for that one we are going with only whenever 1 1 1, at that time only it has to be active. It has to be active only when 1 1 1 is given. By that time only it must be given logic 1. For all other cases, whenever the counter is 0 0 0, or it may be in 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0. For all cases it must be in the clear input should be 0. Only for whenever the counter try to go towards 1 1 1, by that time clear input has to become activated by getting logic 1, and that one will be given to the clear input of all flip-flops, that makes the resetting of flip-flop outputs so that it will go to the initial state. So whenever A is equal to 1, okay, whenever A is equal to 1, B is equal to 1, C is equal to 1, A is equal to 1, B is equal to 1, C is equal to 1, then only you must get logic 1 over here. So what type of circuits this should contain? And that too you are going to use only 2 input gates. So the output will be 1 whenever all the inputs are at logic 1. Output is going to be 1 if and only if all the inputs are 1s. That implies nothing but is it AND gate or not. So here you are going to use AND operation between the 3 inputs, but as you are using only 2 input gates at that time, first you are going to connect 2 input AND gate, and the output of that one is going to be connected to the another 2 input gate. So this is what the circuitry you are going with. So this is connected to B and it is connected to A, this is connected to C. So if you are connecting in this way, okay, at that time it is going to be performing 0 to 6 counter, and whenever the counter try to goes to 7, it makes the resetting of the flip-flop so that it is going into the initial state. So the right answer is nothing but the combinational circuit is consisting of 2 AND gates. 2 AND gates is nothing but the right answer is D. Right answer for this question is 2 AND gates.